Rewrite the quadratic in the form y equals a times x minus h squared plus k to find the vertex, the range, and to graph the function. When you want to put it in this form, basically what we're asking you to do is to complete the square. The first step in completing the square is move the constant to the other side of the equation. So we have y minus 5 is equal to 2x squared minus 6x. Our next step is to try and get this leading coefficient out in front of the parentheses. So we factor out the 2. We don't factor out what's common, we just factor out the leading coefficient. So we have y minus 5 is equal to 2 times x squared. And if I factor 2 out of my 6, that leaves me with a negative 3x. Our next step involves taking half of this leading coefficient so that we can factor out the exponent. And it's not really factor out, but to write it in the correct form with the exponent on the outside. So if we take half of negative 3x, and it's not the x we're taking half of, just the leading coefficient, so half of negative 3 is negative 3 halves. And now our exponent is on the outside of the parentheses. We are no longer balanced. This is not an equation because this is new. This negative 3 halves squared was not in the original problem. So negative 3 halves squared is positive 9 fourths. 9 fourths times 2 is positive 9 halves. When we add negative 5 to positive 9 halves, we must think of negative 5 as being a fraction. So we have a negative 10 halves plus positive 9 halves gives us a negative 1 half. So we have y minus 1 half equals 2 times x minus 3 halves squared. So to put it in this form y equals, we need to get rid of this negative 1 half. We add a positive 1 half to both sides of the equation. So when we have it in this form y equals 2 times x minus 3 halves the quantity squared plus 1 half, we have it in the form that we can read off the vertex. The x-coordinate is the opposite of what's inside with the x, which would be positive 3 halves. And the y-coordinate is the number that's added on the outside, the constant. So if we were to graph that 3 halves, 1 and a half and a half, we could be here in the middle of space, or we could indicate to the instructor that each one of these markings on our grid is a half. And that way we'd go 3 halves in the x direction and 1 half in the y direction and have our point for the vertex. To graph this, we would want to find a few more points to make an accurate picture. We know the vertex is 3 halves. That goes right in the center of our listing of points that we're going to try. If we go on both sides of that vertex by a same increment of measure, then we will have the y values be the same as well. So let's go back a half, which would be to the number 1, and forward a half, which would be to the number 2. And we can put these numbers back in the original equation. 2 times 1 squared. 1 squared is 1, times 2 is still 2. Minus 6 is negative 4, plus 5 is positive 1. So now we're at the point 1, 1. And our value, our next point would be 2, 1. And you can put that back into the equation and double check it if you'd like. So we can see that this parabola has a U shape. It's opened upward, which we knew because the leading coefficient was positive. And it's relatively skinny. This doesn't look any skinnier than it's been in the past for a normal parabola that has a leading coefficient of 1, but that's because we changed our scale to make our scale twice as wide. So this looks somewhat normal, but in fact if we were to shrink it back down to a scale of everything being 1, this would be a thin parabola. So we found the vertex and we have graphed the function, but we still need to talk about the range. Range always goes from the lowest point, and for this that is the point here, the vertex, and the lowest y value it has is 1 half, to the highest point. And since this goes up and up forever, our range goes from positive 1 half to positive infinity, and infinity is never included.